Hey guys, we're going to have a little look about some special relationships that exist in our unit circle. So I'm just going to go back to our basics where we have point P, X, Y that's moving around our unit circle. Our circle is of radius 1. And if we define our angle of rotation as the angle with the positive x-axis here, our theta, what we know already is that sine of theta equals opposite over hypotenuse, y over 1. Or we can just write y. The cos of theta is adjacent over hypotenuse, which is just x. And the tan of theta equals opposite over adjacent, which is y over x. So straight away you can notice our first relationship. If we come down and have a look here. And we say, here's a trig identity, a relationship that holds true anywhere in our unit circle. Tan of theta is equal to y over x. Y is equal to sine of theta. And x being the cos of theta. So this is our first basic identity relating to the unit circle. Another one, if we go back here and have a look, we say, I see a right-angled triangle. Well, what do we often think about when we see right-angled triangles? Aha, that's right. We often think of Pythagoras, don't we? So let's go over here and have a look what Pythagoras tells us. In this triangle, we'd have x squared plus y squared equals 1 squared. So let's write that down. X squared plus y squared equals 1 squared, which of course is 1. But if we come over here and have a look, our y is equal to sine of theta and our x is equal to the cos of theta. So when we substitute those in, we will have cos squared theta plus sine squared theta. Remember, that means cos of theta all squared. I'll just write that again. Cos of theta all squared. That's just a shorthand way we often see it. Plus of sine squared theta equals 1 squared, which is 1. There's another one that we need to get familiar with. Of course, we might see this written lots of different ways. We may see this. If we took the cos theta over the other side, you may see sine squared theta is equal to 1 minus cos squared theta. Or if you did the same over here, you may see cos squared theta equal to 1 minus sine squared theta. Okay. Now you don't need to remember these ones here, this little fella here and this one there in your formula booklet, but you do need to be able to play with them. We're going to do that in just a sec. Alright, so let's have a look at how we use these two identities that we've just been talking about. Okay, so let's go over. Okay, let's have a look. We might be asked, for example, to simplify an expression. So let's say we had this one here. Let's start with a nice easy one. Let's say we had 3 sine squared theta minus 3. Remember, another way of writing that is sine of theta in parentheses squared. Okay, so we look at that and say, right, what do I feel like I could do here? Well, see a 3. We might want to take out a 3 as a common factor. So let's do that. Take 3 out. What are we left with there? We're left with sine squared theta minus 1. And now we can look at that and say, aha, that looks vaguely familiar, but not quite. I know this, sine squared theta plus cos squared theta equals 1. So I know that cos squared theta equals 1 minus sine squared theta. But that's not what I've got here. It's the opposite, it's minus 1 lot of this. So what I could have done, instead of taking 3 out, I could have taken a negative 3 out, and I would then have 1 minus sine squared theta, which I can say, aha, look at that there. I can use my identity that 1 minus sine squared theta is equal to cos squared theta. And so I've got negative 3 cos squared theta. There's 1. All right, let's have a look at another situation. Let's go back to blue. Let's say, once again, focusing on simplifying, let's say we had to simplify, let's do one like this, sine x plus cos x squared. And so we've got that. Well, we look at that and say, oh, yeah, that's almost an identity. Sine squared plus cos squared theta we know is 1, but that's not quite, is it? So we look at that and say, well, we may expand. So if I come down here, I'm just going to remind us of our basic expanding. If we have a plus b all squared, we know that's a squared plus b squared plus 2ab, don't we? So I'm just going to apply that here. So let's do that. So we've got sine of x squared, so sine squared x, second term squared, so plus cos squared x plus twice the product, so 2 sine x cos x. Okay, now you might start seeing some things here. We can put those together. So we've got sine squared x plus cos squared x plus 2 sine x cos x, and we know that is an identity of 1. So we can write 1 plus 2 sine x cos x. So there's another way of writing that binomial squared. Okay, and we'll do one more before you guys are going to have a go at some. Let's try this one. Once again, let's see if we can simplify. Let's try this. Cos of theta, let's go back to theta, plus tan of theta, sine of theta. Okay, so let's have a look what we've got there. There certainly doesn't seem to be any sort of sine squared plus cos squared going on, but we do see a tan. So let's see if we can use our trig identity, see if that helps us anyway. So we've got cos theta plus our identity for tan theta, going back to our unit circle, was sine theta over cos theta, y over x, cos theta, times the sine of sine of theta. Okay, let's have a look now. We can go over here. Well, can't cancel, but we've got to multiply here. So I've got cos theta plus sine squared theta over cos theta. Doesn't seem to be simplifying. Let's have a look. We have two terms. One's a fraction. Well, how about we add those fractions? My common denominator here I could have as cos theta. Now, what am I multiplying this denominator by to get cos theta? So I've got to multiply the top by the same thing there. So what do you got on the top line now? Cos squared theta plus sine squared theta. And we can say, aha, I know that that's my Pythagorean identity, and I can say that's 1 over cos theta. Awesome. All right, I'm going to give you a couple to do now, and we'll get back together in class and have a look at these ones. All right, oh, let me pick my blue. Okay, could you try these ones, guys? Let's try, here we go, simplifying. Let me see, what's a nice one? Let's try cos theta over sine of theta plus tan of theta. And let's try another one. Let's try, I think that says sine of theta over the tan of theta. All right, guys, see you in class.